Okay, here we are factoring perfect squares, differences of squares. We notice there's no middle term here. Okay, we look at the numbers 9 and 25, and those are perfect squares. Very key there. So when I see that, and there's a minus sign in the middle, I make my two sets of parentheses. One is going to be a positive, one is going to be a minus sign. Then I look at my number. We have 9x squared. Okay, the square root of 9 is 3. 3 times 3 gives me 9. So I'm going to put a 3 and a 3, and then we have an x and an x. Now I look at 25. It's a perfect square. 25, the square root of 25, 5 times 5. 5 and 5. Therefore, our final answer is 3x plus 5, 3x minus 5. It will always be the same but different in the middle. Number 2. Okay, we double check. We see there's a minus sign in the middle. There's nothing. That middle term is gone. We have 81 and 4, and those are perfect squares. Therefore, I can make my two sets of parentheses. I can put a plus and a minus. I look at this first term, 81x squared. Square root of 81 is 9. So I have a 9x, a 9x. 4y squared. The square root of 4 is 2. So I have a 2y and a 2y. So we get 9x plus 2y, 9x minus 2y, which is choice A. Okay, number 3. Again, we double check. We see we have 25a to the third minus 16a. Okay, this one's a little bit different because I can actually pull something out. I see that I can pull out an a out of both of those. So if I pull out an a, I'm left with 25a squared minus 16. Okay, so now I see I can factor these down. It's a perfect squares here. I can't forget this a here. And now I'm factoring this here. One's a plus, one's a minus. The square root of 25 is 5. So I get 5a, 5a. The square root of 16 is 4. 4 and 4. So we get a times 5a plus 4, and then 5a minus 4, which is choice C.